So welcome to SRB027. Dave told you guys, but this will be my last SRB meeting. So I guess part of the process will be electing a new chair.
Searching for a solid replacement.
Okay, so that sounds good. We have an adoption of the agenda. I'll give it to you, Dave.
Okay, well, thank you very much. And we'll make sure we send up tonight a function for you. So.
Well, I'll be hungover for tomorrow's meeting.
Okay, so on the screen, we have the agenda. We have some feedback coming through. To see if we can get rid of that. So hold tight for a moment. Okay, so in terms of the agenda, we've gone through, adopted the agenda. I can also have another business item at the end in case you do think of anything else that needs to be added. We have agenda item 3, which is a discussion of the IPHC process or processes. And just a reminder that under 3.1 with the SRB annual workflow, that this meeting is now primarily designed to develop recommendations to the Commission to consider at the IM 101 meeting, which will be held on the 2nd of December, so the interim meeting, and then also for further consideration at AM 102 in January next year, 2026. In terms of updates on actions arising, this is under agenda item 3.2. Could we just have the paper for document 03, please? So this is just our standard update and actions arising from recommendation or requests from the previous SRB meeting held in June of this year. No surprises, you're familiar with the format in terms of how we try and structure those recommendations and requests, and provided at Appendix A is the list of recommendations and requests arising from that meeting, what a description of what that recommendation or request was, and an update on progress. So at various points throughout the agenda over the next couple of days, we're going to revisit each of these actions arising and provide you with a further update. There's still quite a few that are either in progress or yet to be are pending. And so if you can just keep that in mind as we go through each of the presentations today, tomorrow, and we can see if there is a further update, noting this paper was published 30 days ago. So I don't have any specific updates there. Each of the presenters are going to provide a very detailed update. We've provided the links to papers if they are provided for this meeting. Otherwise, it's more just for information. Similarly, paper 04, don't worry about bringing this one up on screen. Paper 04 is the exact same paper that we put up for reference, which is the outcomes of the last annual meeting. And so you considered those at the June SRB meeting. And it's just for information and quick reference. And it was primarily around discussions around some of the AI work that's ongoing at the Commission and the interest of the Commissioners in particular in that AI activity. So before I jump on to the next paper, just quickly, any questions or comments on those two informational papers? Okay, not seeing any. Then we might jump back to the agenda, please. And so the next agenda item, 3.4, is our standard update from the science advisors. And so I see we have Anne-Marie online. So Anne-Marie, any updates from you?
Good morning. Yes, have a couple of things from the commissioners, but first, Sean, congratulations for upcoming retirement from SRB.
Thank you.
And I guess I've got 3 main topics, one on the HSP, the Harvest Strategy Policy, one on sampling associated with research, and another sort of a perennial 5th question. Do you want to take one at a time? They've sort of got multiple questions within each sort of topic.
One at a time, please. Yeah.
All right. So on the harvest strategy policy, all the questions are around the definition of depleted that's being suggested. There's basically general questions about, are there examples from other places that have implemented this concept? If so, what's been the experience with that? And then some general questions around how would we actually implement the concept in terms of, like, do we identify indicators that would ensure that we don't get to a depleted state? Would there be specific actions or levels of actions that would be taken prior to getting to a depleted state? And how would we go about identifying these indicators and actions or other things in terms of just general implementation around the concept of depleted?
I know Alan was the one who discovered that. It was from New Zealand. I don't think if there's other examples. I mean, I know there's people who would like to have something like that because, for example, in our fisheries and shrimp, Atlantic halibut, they're always concerned with fisheries-induced depletion specifically, things that are related to fisheries.
No, I think that's exactly it. Here at IPHC, we have the ability to really look closely at our harvest strategy policy and develop it appropriately, I feel. And we've developed the concept of dynamic relative spawning biomass. So we're using that, and we've been using that, which is measuring the effect of fishing. But I think we discovered that it's really important to bring in the depleted concept to get at that idea of what if the stock is just generally low in size. And you'll see I'll present some stuff today that will begin looking at how do we identify these thresholds, what are indicators and things. So I think we're going to talk a bit about these questions in my MSc presentation that I'll give either this afternoon or tomorrow morning. But I think these are really good questions, and I'm actually encouraged to hear that the commissioners are asking these questions. These are the things that we do need to work on.
Great, thank you. And the second question is around.
I want to add a placeholder.
Oh, cool.
Maybe we can talk about some free times. Is like, what do you do in a case where, like in Pacific halibut, where weighted age is not under your control, clearly decreasing stock, that's putting the biomass down. At what point do you say that enough? Like, you don't have control over that. What do you do about it? Okay. Be curious to see at least make sure it's clear what would happen in that scenario.
Yeah, I agree. That'd be a great discussion to have.
Okay, number 2.
Thank you. So number 2 is around research and sampling, and Joseph actually answered, and Ian answered a lot of these questions when we were at the whatever meeting we were at a couple of weeks ago, the commissioner's work meeting. And so I think the only and the questions were generally around the separation of maturity and fecundity sampling. And so I think the questions are now more along the fecundity sampling, because that's not done through the FIS, so those have a separate collection. And so Joseph had indicated that there's one more round of collections for 2026 in 3 of the regulatory areas. And so I think he mentioned this, but I think I just forgot and didn't pass this along to the commissioners, was what are the plans for after 2026? And it sounded like it might depend on the results from the 3 years of data that's already been collected. And so I was wondering, like, how long that would take, and like, when would we know what the next steps are?
I think I can answer that. Do you guys hear me?
Yes.
Yeah.
Okay. Yes. So yeah, that is correct. We had a research plan aiming at collecting fecundity samples in 3 consecutive years. So we started in 2024 in the fall. That was followed in the late summer early fall of this year of 2025. That's completed already. In both years, the sampling was conducted in the same region, the Charlotte region in British Columbia, IPHC Regulatory 2B. And next year in 2026, the plan is to revisit that same area in IPHC Regulatory Area 2B, but also to include sampling in other areas to not only attempt to characterize the temporal variation of fecundity, but also the spatial variation of fecundity. So the plans are to also sample biological regions 3 and 4 in the late summer, early spring of 2026. With that, we have now more than 1,500 samples for fecundity that will need to be analyzed. So it's a little premature to say when we're going to be embarking in the next round of fecundity collections, but what I can say is that next year in 2026 will be extremely busy processing samples for fecundity. And I would anticipate that it's going to take us, I would say, a couple of years to really get a good grasp on fecundity from a temporal and a spatial point of view. I also want to note that this method for fecundity estimations is not in place in the IPHC lab. This is a method that needs to be set up. That will take some months, and this work will start this fall. But again, the fecundity estimations will continue for quite a few months, well into 2027, I would expect. When we get the initial results, then that's when we're gonna start looking into the future for future collections. I think that's all I can say for now.
Thanks for that.
Yeah, thank you.
It's just those two?
No, the last one is sort of a preliminary one, or no, a perennial one that keeps coming up and up in terms of fish design and what level of precision and accuracy that we need. And I think I just need to go back and pull up a lot of the work that staff have already done in terms of that. But I'm also wondering whether there are specific questions that, for example, that the science advisors can put in front of the commissioners that would help them think about like what sort of, because I know that, what am I trying to say? I know that what staff have said in the past is that, okay, well, we can do just coast-wide and have a much smaller footprint in terms of a FIS, but you would not have the information that you need or that you're used to seeing for distributing TCEY to the regulatory areas. And so I think, and I'm wondering whether there's any additional those types of questions or any other things that we can provide the commissioners to provide feedback for staff so that it's not this perpetual question of, is the FIS footprint too much? It's like, well, it's too much for what? And just trying to figure out how to break this little cycle of of the FIS survey design questions.
Thank you. All right. So let's make sure we talk about that when the FIS comes up.
Great, thank you. That is all of the questions.
Okay, thank you.
Okay, looking online, it doesn't look like we have Pete joining us. Is anybody aware of specific concerns that US commissioners have raised that Henry hasn't just raised?
Well, I guess at the work meeting, there was some discussion about prioritization of 2A. And that's an interesting one because it's a very small fraction of the coast-wide biomass. So from a stock assessment perspective, it's a relatively low priority, even to the point where we might not know what was going on in terms of trend in 2A.
but it's extremely critical for the management within that area. And so I think this is maybe an example that links to what Anne Marie's talking about, which is that our pure assessment goals are not sufficient to cover a lot of the management supporting information questions that come up, such as what is the trend of 2A and making decisions about 2A. And although the commissioners haven't given us clear guidance on how they would like to prioritize stock distribution estimates, it's clear that they are still very interested in stock distribution. And that's where I think that's maybe I'm paraphrasing incorrectly, Anne Marie, but I think that's part of this loop that you're talking about, which is that we say, well, we don't know how important that information is for you. And they don't tell us. And so every year we continue to wonder.
Yep. Yeah, it does seem like a very circular discussion that we have.
And I think there's general interest in the concept of depleted, as Anne Marie explained, with the Canadian commissioners as well. So similar questions from the US commissioners. They're looking forward to the work that we'll be doing in the next year or two to help understand that.
The U.S. commissioners have experience with the U.S. federal fishery management system.
Commissioner Kurland is the NOAA regional administrator in Alaska, and he's quite familiar. He brings up the Magnuson Stevens quite a bit. Commissioner Alverson has been in the system forever, and Commissioner Yamada is having discussions with him. I'm really impressed with how knowledgeable he is. So I think they're aware of it. I think where some of the confusion comes in is we're using terms like relative responding biomass, which are used differently in different arenas. You know, relative responding biomass might be relative to B0, an equilibrium fixed concept, which would be like a depleted that we're talking about. So we've been trying to explain those differences, but I can only imagine when you're jumping between Pacific Council, North Pacific Council, federal, and all these things, those terms, it's hard to keep it all straight. So.
It seems like it is very analogous to the overfished.
Yeah.
System like that brings back to.
Right. And the question we have is, well, how do we define what B0 is in that concept of depleted in that sense? Is it when weighted age is high? Was it when weighted age is low?
But I think the idea of depleted was to separate it.
Yeah.
Fished.
Yeah, I mean, the term,
Yeah.
you can call it something different, but it's status biomass relative to some fixed, non-dynamic reference point.
So we've been working on just educating and making that really clear in those definitions. So that's something we've been doing.
And I think we had some discussion last time to try to not necessarily link it to any equilibrium zero, just we're talking about picking, here's a biomass. Biomass that represent that state.
And so I'll present some work that we did on that to you this week.
Okay.
But Anne Marie, is it okay just to help with the report, and I particularly noting that last point you raised, if you could just provide a quick summary of those 3 points, what the concerns were, and then summarizing what the responses were in the room, and then we'll add that into the report. And we'll also add in those couple of points that the Secretariat feels are of interest to the US-based commissioners. And if Pete is able to join us over the next couple of days, we'll get him to chime in with any additional feedback as well.
Sounds good. Thank you.
Okay, moving along then. So on to agenda item 4, which is the integrated program of research and monitoring. So we just have paper 5 up on the screen, please. Okay, so there's no specific presentation for this paper. This paper was provided to you, I should say the draft, which is the 5-year plan, which is provided in Appendix A, was provided about 45 days out, and then a revision 30 days out for this specific meeting. And so the 5-year plan has been updated based on discussions at the SRB over the last year, but also in previous years as well. It incorporates some more general factors, such as the uncertain funding environment that we're facing over the next number of years, which has brought a lot of uncertainty in terms of what we feel we can achieve within a certain short-term time period. But with that said, the plan really builds on those first two plans, the 2017 to 2021 Biological and Ecosystem Science Research Plan, which was led by Giuseppe and his team, and then the first 5-year program of integrated research and monitoring from 2022, which is due to be wrapped up at some point in 2026. So this new plan doesn't have a time period specified within it. We are just looking at rolling it forward and updating it based on Commission and SRB recommendations on an annual basis if there are modifications or redirections that are required. So look, with that said, I'm just going to pause and see if the SRB has had an opportunity to really dig down into the various components of the research plan, and if there are areas that you'd like to see us redraft or that you feel are missing based on guidance that you've provided in recent years. So I'll pass to the SRB.
I have some. Start. So on that last point you made there about the rolling timeline for it, there's a lot of planned activities in there and everything. And yeah, it's kind of open-ended, but it would be interesting if there was like a more tactical, like 3 to 5 year schedule of deliverables or something like that, just so that you can see, okay, this is coming to be delivered in this particular time. If the plan is meant to create a plan and keep people accountable to the plan, that would help in that respect. On the overall research themes, we've always emphasized making sure that research is linked to some element of the assessment or the MSE. But there's not really a clear way to prioritize those things, especially if you're in a difficult funding environment. You want to make sure you're doing the work that you have money for that is the highest impact. So for some topics, for example, even within, okay, the country is going to be using the assessment, but it would be interesting to see, like, how does that rank relative to depredation, to discard mortality, or these other research topics, climate, and so on. So just like a prioritization element to it. I'm not saying these have to be done like right away, but if it's a living thing, these are things that could be. There are 2 of the performance review recommendations that remain to be completed. It didn't really say when those are going to be completed or how. It's just kind of these are left to be done.
Which ones are those? Sorry, just trying to refresh my memory.
The Pan-Pacific collaboration and the observer coverage scale to fishing intensity. Has that been looked at? I haven't heard. I mean, if it's something that's not practical to do, then it should be, I don't know how that works with independent performance reviews. If you can say, yeah, that's a great recommendation.
Yeah, no, we certainly can, and the commission has done that with a number of other recommendations related specifically to the operation of the commission. They've just said that, no, we're not doing it now. We acknowledge it, but it's not a priority, or they've done that with at least one of the recommendations from the performance review, and so we can certainly do that with these from science-related recommendations.
And something that's always struck me coming from 2B is how, you've got almost down to the pound accounting and monitoring of catch in 2B fishery, whereas other ones are kind of 10% observed coverage on this fleet, whatever else. So in terms of the monitoring system, that would be something that, I don't know. I don't know if there's anything you can do about it, but certainly it would be good to have an evaluation of that. What observer coverage is like across the regulatory area. And that kind of relates to another communication. A couple of years ago, I did something for the Halibut Association. It was actually, it spawned out of a multi-species project we had, and we came up with a dashboard. You guys have dashboards you give anything? Maybe you had one on one of your web pages, but we looked at in that case it was multi-species fishery, and so we were looking at, okay, what if you had a picture of all your species that are involved by sector, longline fishery, trawl, and trap are the ones we're looking at, and each one has its main target species and its bycatch species, and reporting on the status of each one just in one place as a dashboard. It would be used as an easy reporting mechanism. I mean, you guys produce lots of tables and stuff, but
Yeah.
I mean, if there's a way to kind of summarize the stock assessment or something, key indicators that people would just get a snapshot of.
This sounds like that. All in a dashboard.
Yeah, I mean, it's interactive.
Interface.
Yeah. And the MSE has the Explorer.
Yeah, but those are things that somebody has to get in and
Right.
kind of, okay, I got to go to this page and that page. Like I was talking about Prawn Association yesterday. I'm giving them all this stuff about, we did this, we did that. They're like, yeah, but we don't read it. Just give me a one pager. How am I going to summarize that in one page? And graphically, dashboards are a thing now. They're kind of pretty. Text for that. But anyway, that's something to think about.
Maybe incorporating the decision table into that dashboard or something.
I wouldn't make it super complicated, but you could say like, here's the regulatory areas.
Mhm.
You need to call them or something. There, dashboard. But you could look at, okay, what was the TCY last year? What were the conditions? You guys might actually do this. Do it for sable fishery. Like, here's all the stats from last year. Here's what they are this year. Here's the change. That's one. But you could do that by regulatory areas so that each on one snapshot, you could see the whole picture.
Yeah, I think the presentation Ian gives at the annual meeting has a lot of that info in it. He has exactly that, comparing last year, this year's TCYs, other things. Maybe we can sort of summarize that presentation in a way.
But that information may be better summarized at the regional level as well. For example, we may have a survey estimate that's better interpreted by region, individual area, depending on the coverage that year, timing, and everything else.
Yeah, if you did it on your website, you could certainly have pages that, or you could, I'll leave that to you. Some of these may come up in our more focused discussions, but thinking about the aging AI, which it's actually machine learning. It's AI. But anyway, if there's a plan for integrating that into the aging process, or if it's still, how long it's going to be in the research stage. Because I remember we've seen it a couple of times now, and I saw some epigenetic work in Atlantic halibut last week, and similar. I was like, well, you could replace your AI, plot of accuracy and precision with that epigenetic one. Like they look really similar. It was a range of ages where it's pretty good, and then it tails off. And so, like, is there a plan? Like, you could use the AI to generate all those ages over the range that it's good at. And if an age comes out in a certain range where it's not good, you can then read those by manual. I mean, that's what I was suggesting they do with that epigenetic agents. You may not ever fix those ones where the bias is just getting worse and worse. You could just chop it off and say, okay, then if AI can read 50-60% of your agents, you just focus on the tougher ones, because they're in a world of hurt, the Atlantic halibut, because they don't have any ages. Their age reader is retiring. She's like on the track now, gone 5 or 6 years. There's nobody being trained. There's no plan to replace her. So it's like, they're going to need some massive efficiency thing. So that.
May I add to that? Can I add? Can I add the response to that comment?
Well, you can respond
Yeah.
if we have a.
So we will not have presentation for the AI for this
Okay.
meeting, just because I didn't have like a major update for the projects. That's why the only update that I have is what we wrote in the research plan. So I will just add that part of the response to the question and the concerns, exactly in line what you've been saying, is that what I presented during the last SRB meeting, I think it really well aligns with those questions, just because when you think about that plot that I showed where we can sort the predictions based on the confidence level, and then normally the confidence level increases for the older ages, and it's just because the model is less certain for those older age categories. But this is exactly can be used as a method to select those autolets for manual aging. So what we're, as a part of the AI project, as I said, I don't have a full presentation just because we didn't have much updates and we don't have much additional pictures for this SRB. So the next update will be for the SRB in June. But we've been thinking a little bit more exactly like how to test it in the stock assessment and looking at more of this approach where we can fine tune the results, we're going to limit the number of manually aged autolets, and think about using the ages based on using AI ages based on subsample, where some of us other autolets are subsample for manual aging based on AI derived confidence intervals. So using those that the model kind of predicts with a better confidence versus those that are predicted with less confidence can be.
And you also know, like in the plots that we've seen, like anything above this age should be automatically flagged. Because the AI might misinterpret confidence. It's all automatic. We end up picking things that or not picking some things because it looks good to the machine, but it's a little imprecise for some reason. There should probably be a hard cut.
So that's why what we would consider it would be some sort of mixed method where we would still have some manual
Yeah.
aging, but just looking at the method that can automatically designate what are those that can be subsample for that manual aging, just for efficiency purposes. And as we added to the research plan, there are ways that we would be planning on testing that in the stock assessment. But that require a little bit more work. That's why we don't have a full presentation for this.
Maybe just to expand on that a little bit, just thinking about testing it in the assessment. It's also, that's a challenging concept if you think about it, because we have 100 years of catch-it age data. We add a couple of years of very imprecise data, we're still going to do fine. Are we testing the performance of this for the next few years? Do we project something out 50 years until we have multiple generations that have never been aged by a method other than AI? In which case, then that's a very different kind of performance. Or do we try to integrate this in for some of our data sets, but keep some data sets based on manual ages? You could have one, you could do the survey with manual ages, and then we could do the fishery with AI. And then we'd still have some rock solid, very defined cohorts. There's the sort of limitless question of how you can implement and test this. So
I forget exactly what so what's the precision difference between the AI and the readers? The aging error precision.
So we continue to have a higher error for the AI aging, but it's becoming lower as we continue adding samples. That's why I think what we see, we currently still did not achieve like a saturation level where adding just additional images is improving results. That's why we are in parallel thinking how to implement it from the kind of more practical perspective, but at the same time we're improving the result with just adding additional images to the training data to put those results. And I presented in June, like you might have seen that we are also running into issue with trying more sophisticated, complicated model. It's not working just because our data set is still too small. And I hope that as we also add additional images, we can move to more advanced models, which can perform better.
Yeah, like thinking about the Atlantic halibut case, like all they have is lengths. So as long as the AI is better than length,
yeah,
you start right away, right? So if you have a case like that where you're maybe back calculating age, that would be filling gaps, right? Filling gaps that are not the top priority would be a great use for that. Then you can always go back and review at some point, correct if you need to. Yeah, the others I can just, I'll give you the whole thing, but those are the main ones.
That's useful. Well, I guess reading this, it seems like a bunch of really useful studies that we've talked about a lot, but it reads a bit as a laundry list because it doesn't have prioritization. Ways of figuring out what those priorities would be. Certainly, it's come a long way in terms of justifying the biological studies in terms of where they fit into the stock assessment, the uncertainties that they address. But there's a whole bunch of more studies that you can do, which is great. Questions. But I think some kind of prioritization here is saying, for example, most of the dynamic productivity that we see seems to be driven by weighted age. that's why we're going to focus the biology program on. So the key studies there. That kind of and maybe that's not where you come out, but that sort of process of thinking about what the really key uncertainties are, and then focusing and justifying the research there. So,
Can I go do one or?
yeah, I was gonna
Okay. One of the things I was in the Atlantic Halibut research meeting last week, and one of the things they asked me to do is prioritize the research that's needed for stock system. So I had to go through and say, okay, if there was nothing else I could do, what would I do, right? What is the key thing that generate risk in this fishery? So anyway, I had to pick, I had to prioritize a bunch of topics. That was the lead-in that I started there. Like, where are the risks coming from? For them, it's like you've got no ages. The whole thing is based on lake data, so it doesn't matter. And everything else follows. Natural mortality, growth, it all falls from that one problem. So I think that's kind of what maybe could be used, right? Is you could, at the top of the research plan, like, here are our main challenges that lead to risk, and then outline those as the. And I think you do. A lot of the research is pretty well prioritized in terms of even that.
Yeah, it might not change the list that much, because
Right.
you guys sort of internally know what things are important, and that's what drives you. But for someone externally reading this, knowing why growth and size and age is a big component here is useful, because that seems to be what's driving the variability. And then it might also lead you to remove some things that are not closely related to that, like investigating dietary composition in stomachs through barcoding. I looked at that one and thought, we have a pretty decent idea from stomach contents. Metabarcoding, given the existing libraries, it's just full of bullshit. It ends up like, I've done this recently, and what you end up doing is saying, we know that this is true from stomach contents. So yes, that one's real. This one we've never seen in the stomach contents, so that one must be an error. When you do that process, you're not learning anything. You're only believing the method that tells you what you know. So I think that's probably what you'd end up doing with metabarcoding as well. Maybe you'd push metabarcoding forward a bit, but I don't think there's a real sort of management benefit that's obvious from that. And I think that prioritization process would result in seeing some of those things drop out. Yeah, this probably is not going to be a priority anytime soon, because there's not a lot of risk to this fishery from not understanding in precise detail what's in these maritime components. The next one that came to mind when I was looking at this is it will be useful to have some decision points in terms of when to continue a research topic and when to end it. It's something we talked about last time as well, right, with respect to stock structure. Like, great, you can call that one successful, done, and move on. When there's external funding, it's easy to decide when the end of the project is, right? When it's internal funding, you can often end up spending more money, more resources on the topic than makes sense. So you answered it to a point. That's sort of good enough for management purposes. So for each of these projects, what's good enough? What is the end point? And section 4, I think, was really a right step there. Section 4 is about sort of how do you assess success. But this is slightly different than that. This is how do you assess when this project needs to stop and we need to put our resources into things. And some of these won't stop. It's mentioned in a couple places that you anticipate this moving from research to monitoring. That's great. How will you decide whether it moves from research to monitoring or whether it just stops? Because the answer is clear enough that that's not where additional benefits comes from.
I had something very similar, which complements yours, which is maybe you also need a supplemental document that keeps track of completed projects. It says, where have they gone? One. And number two, like, because when you complete a project, that may have implications for other projects. So for example, if your stock structure is resolved, as we've all concluded, apprehensively concluded, is there other, because then, reading through, it's like, oh, there's a bunch of studies in there that are looking at, line scale movement and things that are kind of stock structure or research. And it's like, well, should you still be doing that? Want something else. So, and the paid thing is already 50 pages long. Make a giant book out of it, but maybe there's another one that says maybe in your reporting or something like that, in it, whatever the reporting format is. Say, okay, project X is completed, and then the post-project analysis of the research plan, the implications for research.
A couple years ago, we had a spreadsheet of
Yeah.
I think one of the columns there, sort of got unwieldy, I guess, but one of the columns there was
Related to where,
little things. Right. And my last one was about cost benefit analysis. I think that doing that a little bit more formally for some of these projects could be helpful. I think particularly about the AI aging, thinking about what the potential outcomes are. Say AI aging does start to asymptote in terms of the improvements that you get from adding more images, and you do have a sense of what the ultimate accuracy is going to be. Where does that leave you then in terms of how the AI aging fits into the overall process? Does it mean that you stop doing aging entirely? Then you can calculate the costs associated with, or the savings associated with, sort of eliminating the aging process. Or does it mean that you reduce the number of samples that you age because you're only focusing on those where the AI has high uncertainty? And there you can kind of prorate some of the costs associated with that. And I think that process might help you see that some of these advances would be really useful, but they might not replace what you're doing already. And so they're sort of adding on to monitoring costs into the future as opposed to reducing those costs by replacing something else. It would be good to know that, because that, a lot of the subcontext here is about a resource restricted environment and what you prioritize. And it's hard to do that without knowing what things cost and which ones can be eliminated if this particular project works out. Which ones will, in order to be useful, will require adding a new data stream. And so if that new data stream is something that's cost prohibitive, maybe that's your answer there in terms of down prioritizing that research project. That's right.
Yeah, I have actually pretty much the same things, like priority and then the cost benefit analysis. Especially now, if the resource is less abundant than it used to be, it would be important to highlight what are the most important things and what are that kind of the handling resources and time permits. But I was wondering if something more core decision-making analysis to be applied kind of identify that where are the largest uncertainties, what is the parameter in the stock assessment model or some other process that causes a huge uncertainty. And we shouldn't so much focus on estimating because that we already know quite well, or that has very little influence in a big picture. But then, of course, we all know that probably natural mortality has a huge impact, but also studying it is almost impossible. So that's why the costs and benefits need to be quite formally integrated with each other. But some sort of formal decision-making analysis or procedure would be useful because it would get them be completely transparent by certain priorities given to certain process and why not do some other. So it wouldn't be just about the opinion, but about the analysis.
You did have one more. I have much more, but you brought up measures of success, that topic. I was thinking, well, the measures of success may differ depending on the project. So each project is proposed, it should say like, okay, how's success of this project going to be measured? Some of them could be, a scientific publication. It's one. Some of them, such and such was included in the assessment this year. Did some AI ages this year or whatever. But I was thinking about you guys are always trying to improve communication, and commissioners get certain information, they interpret it a certain way. Stakeholders, the fishermen get their information, they get the same information usually, and they may interpret it. Their indigenous groups may do theirs, the processors, like you have all these different groups. You just go to the AGM, right? You just think about who's there. And I'm wondering if there could be a measure related to that. Like, do you ever do a survey or find out like what are they hearing? Are they able to actually use this information? So maybe I don't know if you've done surveys, internal surveys among fishery participants and commissioners and everybody else. That could be a fairly straightforward survey to say, just about the way you're communicating with them and how effective it is. Well, whether they feel like they're informed, what they could use to be better informed, and that sort of thing, just to get some feedback, because I know if we go to conferences, we give talks. One person says, "Hey, I loved your talk," but nobody, like, well, what about the other 99? Did they hate it? Or, it's the survivorship bias thing, right? Oh yeah, I love that assessment presentation. It's the one guy who understood it, So like in teaching, Jim Kitchell told me, like, when you're teaching, you teach to the bottom 30%, not the top. I don't like that. So that could be something interesting to pursue as well, and you could then derive some measures of success from it.
Yeah, and sometimes the measure of success is we look into this and decide this is not something we need to worry about. I think the stock structure analysis was absolutely successful because it established with a reasonable amount of certainty that stock structure is not something we need to worry about. That going in, that if there is a lot of stock structure, we'll potentially get it wrong by it's pretty large. So that's success, even though it didn't end up going into the assessment. It resolved the major risk factor for the assessment.
Remove the uncertainty.
Yeah.
Okay, I think that's probably the biggest discussion we've had on this thing. It's created. Usually it's like, yeah, I read that.
That's really helpful. And maybe just over the course of the next couple of days, if you do great to add it in and add it into the report as you said, things that maybe we can consider in this upcoming version that will be published, and then also in future iterations if there are other areas that we want to continue to develop. Noting what's going to be updated.
One thing we could flag for our side conversations is figure 4. I saw this and I was like, at what point does something no longer simplify? Like, it no longer makes something more comprehensible.
I think it's at the top of every box.
Like in different directions and like all possible directions. Let's just put in 5 boxes. Let's just put in some boxes.
We have had that discussion internally as well. We're on the fence about including it all.
Yeah, I wasn't going to put it in the report. Exactly.
I think it serves a purpose. It shows things are actually complicated.
Everybody knows that.
What is the status with external funding or
Um,
prospects?
Yeah, so Giuseppe and Alan are both on the NPRB. So maybe Alan, you can talk a little bit about Giuseppe, if you're online still, about the current funding environment through the NPRB, but then more broadly, certainly going to be challenging, but maybe we'll tackle that.
Yeah, I've just joined the NPRB board, which has been really, really interesting, and learning about the process. But I don't have a lot of insight into it, but I have seen the funding has decreased to that board, but it hasn't gone away. No, I'm not exactly sure. Joseph may know more about the sources of the funding for the MPRB.
Yeah, I would just add that the external funding from particularly NPRB. I mean, this sort of box or oval pointing towards the biological system research was meant to, I think, and correct me if I'm wrong, mostly intended to indicate that some of the biological system research activities would be somewhat influenced by the availability of funding. I mean, and now that's a real issue, having seen that several of our usual funding sources have actually disappeared from the scope of potential external funding sources. So the questions that different funding organizations want to ask can actually influence the type of activities that we can do with external funding. That does not necessarily influence the activities that are funded internally, but certainly those that are funded externally.
And yeah, I thought some funding might come from industry, but I'm not certain. But Joseph, do you know where a lot of the monies come from through MPRB? Is it part federal? Is it part industry?
Well, it's varied actually, because the funding that MPRB gets is actually non-federal. But it's government funding, but it's considered non-federal. But also at the same time, they do have some funding opportunities that are tailored to provide collaboration with industry, and industry are asked to participate financially. So, if you're talking about their core program, when you go into their RFP, annual RFP, those are funded through MPRB alone, exclusively through their non-federal funding. But then they will have calls that are specific for those industry collaborative projects, and those would be funded partially through industry.
AI says it's oil industry money, settlement money.
Oh, really? Yeah, but they have a number of different programs, and some of their programs didn't have funding, but some did. And so it's they seem to be working hard to keep funding going, but some of their long-term funding is on, I don't know if it's on hold or what, but we haven't reviewed those proposals or haven't been accepting proposals for that type of at this time.
We're half an hour ahead of schedule.
And so I'll just add there quickly, sorry, Chair. Just in terms of more broad funding from the two countries through our contracting party contributions, it does look like, at least in the short term, that we'll still be able to hopefully keep up with inflation. And as part of those contracting party contributions, there is around $1 million, which is dedicated to the Biological and Ecosystem Sciences Research Program, primarily for salaries and wages, etc. But it also includes a base component for that sort of ongoing research support by the Commission. But there's certainly no foreseen substantial increase in that.
Okay. Okay, well, scheduled for a break at 10:30. So are we ready to start up biology and ecology program? Go for half an hour.
I'm ready whenever you are.
Okay.
What do you need projected, Giuseppe?
Well, it's agenda item 4.1.1.
Okay, can you see that?
Not yet, it's loading.
Okay.
Do you see it on your screen?
Yes. Yeah.
Yeah, if you can give me a few seconds, I think it's loading up for me. I'm gonna have to ask you or somebody to pass the slides for me, if you don't mind.
Sure. Maybe I should pass that to Cool.
Are you able to see it, Joseph? I'll pass it forward for you.
No. Yeah, no, not yet. I'm still waiting. It's kind of a big file, so I don't know why it's taking so long, but something's happening. Just give me a few seconds. You know, otherwise we could, I think we could just give it a shot because I actually have a presentation on my computer. It's just that I could not, for some reason, I could not access the Adobe Connect through my computer. I'm looking at the phone and the phone's still updating, but I do have my presentation in presentation view in my computer, so I can actually start doing it. So if we're looking at the title slide. This is a brief report on research activities that we've been conducting since the last SRB meeting, SRB027 in June. So if you go to the next slide, which will be slide number 2, this is the slide where we have our research activities related to the research area of migration and population dynamics. And as you heard, extensively over the last few SRB meetings, and particularly from the last one in June, where we presented you our final results on stock structure. Now, following the SRB recommendation, we've moved into manuscript preparation. So Andy is actually working currently, preparing a manuscript for publication in a peer-reviewed journal, summarizing all the results that we generated related to the lack of population structure. In addition, we've also been working, and next, if you can do the next animation, the next couple of animations, we've been also working on the development of an epigenetic clock for aging Pacific halibut. I'm going to ask you to switch to slide 3 now.
Roger.
Okay. Hold on a sec. Okay. So the objective is to develop a non-lethal genetic method for aging Pacific halibut using finklets. What are epigenetic clocks? Those are molecular aging clocks, that is machine learning algorithms that are trained on epigenomic data from biological samples that include a wide range of ages. Next, epigenetic clocks use as input genome-wide DNA methylation features at cytosine, guanine, dinucleotide pairs, also known as CPG pairs, in GC regions of the genome. If you show the next animation, please. This should show a partial DNA, a short DNA sequence in which several of the cytosines, 3 in particular, are methylated. So the input really is the proportion of DNA molecules that are methylated at each CPG site for each individual. Next animation, that should show a table and that basically depicts a hypothetical example of the methylation status of each CPG site over a total of several 100,000 CPG sites of individuals of known age. So for instance, if you look at each row corresponds to a different individual with a particular age and the methylation level of each of the CPG sites. Next animation. Hold on a sec, it's not showing for me. Okay. So age predicting models, such as elastic net penalized regression models, then rely on the weighted average of methylation across a subset of CPGs. So what you see here in this little cartoon is the weighted average of methylation in selected CPG sites. So therefore, this analysis identifies a number of CPG sites that are that have age-associated methylation, and that are usually found in the order of a few hundred. Finally, next animation, a test data set is used to validate and test the performance of the epigenetic clock, and that is by looking at Pearson correlation or by calculating a median absolute error. So next slide. That would be slide number 4.
Yeah. It says slide 3 at the bottom,
Yeah,
but
okay.
it's technically 4.
Okay, you should see slide number 4.
This is the different species one?
Yeah.
Yep.
Yeah, bear with me just a second. Hold on a sec, please.
Errors depends on the age of your cell. That's what I was thinking. Like, it's not that help with you.
I was trying to get these page down stored. I was just like, this one expands. Oh, I'm sorry. There you go. Gotcha.
I know. Okay.
I apologize. I'm trying to reestablish connection. I lost the connection. And I'm still not seeing the presentation on my phone. Sorry. Okay, hold on.
While we're waiting, what do you guys have known age fish you're going to use in the testing and development of this, or is it?
Yeah, yes, this will be shown in, if I can get to see the presentation, that's on the following slide. Yeah, I'll provide details about that. Okay. Hold on. Almost there.
I had my epigenetic.
Spanish internet connection is not the fastest. It's kind of a nightmare.
I was only 4 years younger. So it's probably in the error. My wife is 8 years younger.
It's good.
Isn't it?
I didn't know this was a thing.
Okay. I'm just going to go ahead and describe the slide without even seeing it because I can't access anything through here, but at least we have audio. So if you're looking at the slide that shows the table, that slide, in fact, depicts the different epigenetic clocks that have developed for fish. But I should state that the first epigenetic clock that was developed was the one for humans, and that was developed in 2013. And subsequently, several epigenetic clocks for a number of fish species have been developed. The first ones in 2020, the first one was the European sea bass. The second one was zebrafish. And then subsequently, different species up until the last publication, to my knowledge, in 2024. And this epigenetic clocks have been developed mostly using fin clips as the genetic material to generate those epigenetic clocks. As Dr. Cox mentioned a few minutes ago, the epigenetic clock for Atlantic halibut is in progress. This is done by the group of Dan Ruzzante at Dalhousie University. They're using fin clips, but that's not published, and we really have very little information except for an abstract that was submitted to a scientific conference. I think it was earlier this year. But so I don't have any details for that. But you can see some of the details in that table regarding mean absolute error, correlation, and the number of CPG sites that were used for developing the clock. So you can see that the mean absolute error for the fish epigenetic clocks ranges from 0.2 to 2.15 years. The correlation spans from 0.82 to 0.99, and the number of CPG size that they use in the clock ranges from 26 to 316. So that's relatively varied. Recent studies have estimated that a minimum of 220 age tissue samples are needed to minimize the error rates. That's after a paper from Maine in 2021. So if you go to the next slide, please, which should be. Oh yeah, I see now that this slide was labeled number 3. Sorry. So the next slide shows, if I can see it first, give me a second. Okay, so if you go through the first animations, Claude, if you wouldn't mind going to the first 2 or 3, you'll see that there's actually a histogram of the samples that we have available for the study. These are samples that have been double aged, so aged twice. So with accurate ages, and the ages range from 6 to 30 years of age. Okay. Before I go on, I should state that this project was conducted with funding from a grant from Alaska Sea Grant. This project started in early 2015. It involved in 2025. Sorry. It involves the work of a master student. So on that histogram, you see the number of samples that we have available, and again, I emphasize that these are double age, so aged twice by two separate readers, so the ages are as accurate as we can get them. And from this collection of samples, we're selecting five fin clips from 5 males and 5 females per each age from the ages of 6 to 30 years of age. So we have a total of 250 samples. Okay, those are the samples that we're actually using for the construction of the epigenetic clock. If you go through the next series of animations, you'll see that the next step, the first step actually, is the conducting reduced representation by sulfide sequencing of all these double age samples. So the process involves purifying a high quality genomic DNA from each individual of the 250 that we have. Restriction enzyme digestion of that genomic DNA, bisulfite treatment of the genomic DNA of the fragments, and then the actual sequencing. The raw sequences are processed and then aligned to the reference genome, and then we get the methylation calls for each of the individuals. So that's really what's inputted into what's step 2. It's the model that the epigenetic model that we're going to be using, and we're using 200 samples for the training model, and then we're going to have 50 samples that are going to be used for the test set. So what we've done so far, and if you can go now to the last animation, you should see a few bullet points under the depiction of the step 1 and step 2. Are you there?
Roger.
So, and I'm speaking from memory because I'm not seeing the presentation in front of me at all. What we have is we have sequenced, first we have processed all 250 samples. Genomic DNA, high quality genomic DNA has been processed and purified from all 250 samples. We've been constructing libraries. At the time of the publication of this PowerPoint, I think the number that you see on screen is something like 168. If I recall correctly, now that number has increased to over 200 individual libraries. So we've almost completed the construction of the entire set of libraries, and 2 pools of those libraries. So we pooled 42 libraries per pool, and 2 of those pools, so a total of 84 samples, have been sent out for sequencing. In fact, it's just 2 samples. Each sample represents a pool of 42 samples, of 42 individual samples. So those have been sent out for sequencing already, and we're actually processing the rest of the sample and making additional pools. So at the same time, Andy has been working hard on developing a bioinformatic pipeline, which is essential for this work. And this has been established already. So hopefully by the next SRB meeting, we'll be able to present the actual results of the predictive model. So that's our aim right now. So that completes the update on the first research area, and I'd like to move now to the second research area, which is reproduction. Unless the SRB board has any questions at this point?
I have
No.
one what are the age predicting models? Are those, you said earlier that it's a weighted average of age by site or something, but are these age predicting models like fitting models at each individual site, or is it collectively averaging them or
No,
something?
I think it is collectively. There's various. I mean, there's a variety of models that have been used for developing all these different clocks. It's not just one, but the one that we're actually going to be following initially is one that was used by the first developers of the first epigenetic clock in three species, which is a collaborator of ours, and that's the elastic model. So that what generates, in fact, is a prediction of the methylation status of each CPG site. So every portion of that reduced represented genome has a probability of being methylated or not. And those methylation sites that are linked with age, those are the ones that are selected for the clock. So that's why, if you remember that table, there's a different number of CPG sites that are used in the different clocks. So that depends on the species, depends on the technique that they use to generate those methylated sites. It depends on a number of reasons, but what we expect using not a whole genome approach, but a reduced representation approach, we're expecting to find age-associated methylation sites that are in the most likely in the level of the few hundreds. So that's what we're aiming for. And then then once that clock is generated, the question remains as to whether you want to use that same number of CPG sites, or you can actually get away with similar results with a smaller number of CPG sites that could be developed into a high throughput assay.
Thank you. Olaf has a question.
Joseph, I remember when we were looking at the AI aging, it performed substantially worse on years that were not part of the training sample. Is this like interannual variation part of your test and training, or is that test data set just a random sample from the training data?
It's a random sample of the entire data set. So we're sequencing 250 samples, 10 individuals, 5 of each sex, from age 6 to age 30. Of those 200, of the 250, 200 are selected randomly for the training set, and then 50 are selected randomly for the test set. I'm sorry.
That certainly makes sense at this stage. You might think about in the future adding a component where you assess that out of sample prediction accuracy across years. Is there reason to think, based on the sort of the mechanics of the method, that it would perform worse temporally out of sample? Is it going to be predicting 2025 ages than a random sample of these 21 through 24 ages?
I'm not sure. I really don't have information to answer your question. I have not seen that addressed in any of the literature that is available. What I can say is that the samples that we're dealing with, the 250 samples, have been collected over a period of few years. If you remember the frequency distribution of samples, those are samples collected in our Fisheries Independent Satellite Survey between 2021 and 2024, coastwide. So those samples are not all collected in the same year, but within within a 3-4 year period.
Yeah.
That's something that we'll definitely need to address that if there's a temporal aspect for the samples.
Yeah, that sounds good. I mean, I guess I'm thinking about different potential use cases for this. One of them might be to go back and age a bunch of archived biological samples from the past, and whether that makes sense sort of depends on how well a model trained on
Yeah.
a few years could predict ages out of that sample.
Yeah, no, that's definitely a good suggestion, and that we'll definitely include that, when we, do the final validation steps of the method.
Yeah. I mean, I think, Joseph, you're kind of in a unique position here where you understand both the genetics and the potential use of this method in stock assessment, whereas all of the previous analyses that I've seen published are just by geneticists testing to see whether there's actually information content there. They're not really doing this kind of out of sample testing because they're not thinking of use cases that would require it. So just because the literature doesn't have that doesn't mean that it's not an important step for making this useful within the sort of overall context of stock assessment for Pacific halibut.
Right. Yeah. Thanks for the comment.
One other question. I've heard some, maybe it's just speculation, but that those non-age-related methylation sites, the ones that are kind of rejected from the predictive model, could be markers of cumulative stress. What's the status of that? Is that well established, or is that still pretty speculative? And if it's established, can you use that information as well?
Yeah, I heard also that as well. I don't think it is established. To be honest, I don't know the literature on top of my head right now. But what we were actually thinking is that that's definitely an interesting, an interesting aspect to look into. But I think for us, it would be actually more interesting to look at possibly the functional implications of the sites that are actually methylated in relation to age, because we may learn something about the aging process or longevity in Pacific halibut. So we'll definitely consider both things. I'll keep an eye on the literature. We'll definitely keep an eye on the literature on those stress related effects on sites that are not selected by the model. But we're also interested in looking into the potential functional aspects of sites that are selected for the model, because we have a fully annotated genome, and we could actually identify the genes that are actually showing methylation in relation to age. So, and that's a pretty interesting opportunity for us to dwell a little further into what's driving age in Pacific halibut.
An epigenetic M estimate in the future.
If there are no more questions, I mean, my audio is good. The visual aspects are pretty terrible. But what I'll do now is I'll pass the word to Colin, who's going to speak to a few updates on our reproductive research area. So go ahead, Colin.
Yeah. All right. Thanks, Joseph. Yeah. So first thing is obviously last SRB, we made some strong headways in being able to implement some new maturity ogives into the assessment. So currently we are in prep for a manuscript using those 3 years of histology data. We're hoping to get a draft out by the end of this year is the goal. And then this summer, what we did was we looked at what are males doing. So if you recall, back on the original reproductive assessment project, which occurred back in September of 2017 to August of 2018, when we first characterized the full annual reproductive cycle for females. During the same project, we also collected males and testes samples from males. So we targeted 30 males from every month from September to August in the Portlock region, which is the central Gulf of Alaska. And all the males were 70 centimeters in foot length or greater. So looking at this information using those 30 males by each month, we looked at the GSI index or gonatosomatic index for these males. And what we found was that they basically are following the same trend as females. Their testes in size are getting bigger starting in roughly about September through the fall and early winter months when females are also preparing to spawn. And we also, while we were collecting these males, we had the field staff indicate sperm production or identify sperm in the testes. And what we found was that males are showing a longer time period of what I would maybe consider readiness. They are showing spermiation starting in November, but also continuing it through the winter months all the way until about April. So basically males are getting ready and probably just waiting for females is kind of the assumption that we're identifying here. So they're continuing to have spermiation through longer periods than what females are showing, because females their primary spawning time period is about January, February. And so males are actually showing a little bit longer progression. So that way, if maybe there's some females that are a little bit delayed, there could be males nearby that are ready to spawn with them. And so what we did also was with these males, we collected testes samples and we sent them out for histology. And we were able to classify the reproductive characterization using histology for these males with 6 stages of development. So if you recall females, we've identified 9 different stages. For males, we have 6 stages using histology, and they're shown here on the pictures on the top figure there. Through early spermatogenesis and mid to late spermatogenesis through stages 2, 3, and 4, which show indications of different varying levels of cellular characteristics. So stage 2 is the beginning of showing spermatocytes. Stage 3, you're beginning to see spermatids. And in late spermatogenesis, you're actually starting to see the actual development of sperm or spermatozoa. And then stage 5, which you see on the top right there, is basically the full testes is full of mature spermatozoa. And then stage 6 is what we indicate as being post-spawn or spent individuals. And so using these 6 stages of classification in histology, we were able to do what we did for females and actually characterize the annual reproductive cycle for males within the Portlock Charter region in the central Gulf of Alaska. And what you see here is stage 1 is in the dark blue. And as you go up through warmer colors, you start getting later stages of spermatogenesis. And then the dark red is the post-spawn spent individuals. And what you see here is that starting in about March through the spring and early summer months, you have a lot of stage 1 or post-spent individuals. So they're basically getting ready to start spermatogenesis. And then starting in about midsummer, July through about early fall in October, you have a lot of stage 2 individuals. So you're starting the early stages of spermatogenesis. And then stage 3 is a lot during the green, during the mid fall months. And then stage 4, they progress into stage 4 in the late fall in November and December. And then once you hit December and January is when you have a lot of the males that are fully ready to go for spermiation and a spawning event. So then also what we wanted to look at was some biological indicators by histological staging. So we looked at GSI, HSI, Fulton's K, which is a condition factor, age, and they also used a fat meter to look at percentage of fat on the individuals. And here's what we found. So GSI is on the top figure. You see that there is a significant increase in the size of the testes based on body weight as you go from stage 1 up to about stage 3, and it levels off during stage 3 and stage 4, and then stays elevated through the full development of the testes, and then significantly drops off once they had their spawning event and post-spawn individuals. Next was HSI. It had a significant increase between stage 1 and stage 2, and then a slow drop off as you progress through spermatogenesis into stage 6. Also, condition factor was elevated during the spermatogenesis stages between stage 2 and stage 5. And then there was no significant differences between the age of the individuals and the stage that they were classified as, and also no difference in the fat. So this kind of just gives us a general understanding of what males are doing during the reproductive cycle and how they match up with females. The next big thing for us is being able to classify males, immature and mature, using histology. We're not quite there yet. It's going to be a little bit more complicated than females. Females have a little bit more, I would consider to be indicators in a histological slide that would be able to determine whether it's a mature individual. You potentially could have post-ovulatory follicles and those types of things. Males, from what we have seen, tend to have like discrete step-by-step process, and then they just go back to stage 1 and then they go through the cycle again. So we're going to have to maybe look at the literature a little bit and what people have done looking at male histology staging in fish.
So that stage 6 is not post-spawning, it's not equivalent to the follicles.
Well, it is a little bit, but there's potentially, I would say that the females show different developmental indicators on the histology slide. Like if you were to look at a female versus a male is very like discrete. It's like you can identify it, whether it's a stage 3, stage 4 within like seconds. Female, it takes a little bit more time because females, we are basing it off the most advanced stage on the slide. So females, they're batch spawners and they show, discrete fecundity. So it's like, so they could have some immature cells as well as some mature, whereas males, they're just progressing through spermatozoa for sperm to be released into the water column, right? So it's a little bit different in the way that you'd be able to identify an immature versus a mature male. But that's something that we want to look at because, one thing that Ian and I have talked about a little bit. So we did have an intern this summer that that gave us some insight into potential size at age divergence between males and females at young ages, looking at trawl data from the Bering Sea and the Gulf of Alaska. So if we're able to classify immature and mature males using histology, that will allow us to also build maturity ogives for males. And we can see the differences between males and females and whether or not those potentially line up with where size at age is diverging with those species, with the different sexes. So that's something that could be a next step in the process of this. So that's all I had for this update. I presented all this stuff at the American Fisheries Society just last month in San Antonio, so got some good feedback from people. But I think it's nice to be able to know what the males are doing and coinciding that with what we know about females.
Well, when I was looking at this before, I was thinking of HSI and fat in particular, and wondering whether to what extent they're directly related to the gonad development versus just having their own seasonal energetic cycle that's kind of overlaid on the on the cycle of gonad development. I mean, is there sort of energy going from the liver or fat to developing the gonads? Is that what's happening with the
I would say it's less pronounced in males than it is females. Females is definitely showing a larger increase in HSI when it comes to gonad development for the ovaries. We thought that could be the case for males. It seems to be that the testes size versus overall male body size is not as large of an increase as it is for males as it is for females. Yeah, fat. I haven't actually used the fat meter. I know Claude has.
Is that the BIA, the electrical impedance?
And it's a challenging device to use. I don't know the total provenance, whether we had the same sampler all the time using the device. There's a bunch of things that could go into it, not showing a lot, but traditionally the fat meter has shown pretty stable, small band of essentially of fat, like in the less than 3% range for most animals. That you rarely see it go high. So
has that been verified with actual composition? Yes. Information. So it is correlated with composition.
I believe so, but the caveat on that is the to do a correlation, the best you want some non-fatty animals and some fatty animals, right? And it's been hard to find contrast in the animals, so that's embedded in the correlation. That's the samples that we get, and they tend to be very uniform in their fat content. And it'd be nice to do another correlation where we have some really starved animals that presumably have consume their fat, and a bunch of very well fed animals that are fatty, but we haven't seen it.
It could be they just store their fat liver instead of their flesh.
Yeah.
Okay, well, that's a good point to take our coffee break.
Oh, the HSI really is good.
To change our fat levels.
Yes.
It's needles. I got understand.
Is it a needle?
No, this one
No, I'm not
was.
doing
This
it.
is a microwave. This is a
Oh,
microwave.
really? That's right. Not the needles.
Okay, so we'll take
Yeah, here the only thing,
30 minutes. 30-minute break.
All right, so we're back at 11:15 for those listening online. Thanks very much. Okay, just to kick off again, Giuseppe, are you there?
yes, I am. Yes,
Great.
can you hear me?
Yeah, we'll just pass back to you to lead us off into the next part.
Okay. Perfect. So if you can go to slide number 10, that's a very brief update on the research area of growth. The only update really is that the manuscript that included all the data generated regarding the identification and validation of physiological growth markers was finally accepted in the Journal of Experimental Biology. That's all for that research area at the moment. The next research area is also in a similar stage in which we're busy writing manuscripts for publication, summarizing all the results that we generated over the last few years. So in this fourth area, mortality and survival assessment, we have a manuscript in preparation, which will describe the work that we characterized on discard mortality rates in the charter recreational fishery. So hopefully we'll have a manuscript submitted before the end of the year to a peer review journal. All previous work regarding this research area has already been published in the peer review literature. So next, I'll move on to our last research area, and that's fishing technology, and I'll pass the word to Claude to give you an update on recent developments. Go ahead, Claude.
Thanks, Joseph. So yeah, this is an area that we've talked about before, and it kind of has two components. I'm going to speak to the whale depredation component here at the top, but we also note that we've doing also some collaborative work over the last several years on in particular circle hook modifications to reduce rockfish bycatch using hook appendages with Dr. Mark Lamelia of Pacific States Marine Fish Commission. And I think Ian's been doing a bit of work with him as well on some artificial lights in trawl nets, along with some other researchers. So there is some aspects of your research that's also we're not reporting on today, other than the publications. So we have been conducting a second phase of our depredation work, and this has been focused in on the shuttle design as opposed to the shroud design. And we secured a second round of funding from the Bycatch Reduction Engineering Program, or BREP. It's listed on the upper right there, to attempt to test the shuttle in the presence of depredators, with the goal of refining and characterizing the performance of the shuttle in those conditions. Joseph, Ian, and myself were aboard the Oracle from the 21st to 28th of May of this year. Over those days, we made 18 sets, and 15 sets of that had both shuttle and control catch for paired comparisons. And 6 of those sets had confirmed presence of orcas. And we have some preliminary data that I'll present here today. We're still working through this. There's a lot of video footage that's helping us decipher how the unit is performing underwater. And it's doing what we think it's doing. Collected over 80 hours of underwater footage, and with the help of an intern, we've gone through about 70 hours of that to date, which includes 10 of those 15 paired sets. These are just some images from that field work. That's the vessel on the left there. It had both a crab launcher that you see in the second image that's just below the shuttle device that we stowed the unit on when we were transiting, and we would, on the second half of the study, we actually started using that to launch the device into the water after it was threaded onto the ground line. This device is sent down the ground line upon retrieval, and it essentially harvests fish near the bottom of the ocean. And then it hits a pre-installed stopper once it's gone over 2 skates of gear, so over 200 hooks. And then the stopper rigging draws the whole unit back up to the surface, and it's unloaded in stage.
It goes back.
Then we stow it until we need to set it again. Yeah, and each time we set it, we start hauling the gear, then thread it through the unit and deploy the unit on. So it weighs about 220 pounds, empty.
Yeah. So you said it goes 2 skates of gear, comes back.
Yeah.
You have more skates.
And so the way we had it configured was between those sorts of treatments, we would have a blank skate of gear that has hooks on it that allows us to thread it on again and redeploy it. As long as you have pre-installed stoppers along, you can keep redeploying it as you will. The original configuration in the toothfish fishery, they actually, I think they run it on different numbers of skates or amounts of hooks that they go through, but they set them with the gear, and they just have them lying on the bottom of the ocean. Mm-hmm. And when they go to haul it, just lifting up of the gear has it start sliding forward until it hits its stopper. Then the next one continues on for the next set of gear. So they have multiple ones on the bottom.
So it's the skates are sliding through it while it's sitting on the bottom.
It is riding just above the bottom. And so as the ground line comes up, it makes it kind of move forward or roll forward. But it's actually off the bottom. It's not colliding with the bottom very much.
You have cameras on?
We did for this project, yeah, and I'll come to that. The third image there is a typical sign of depredation where what's called lips only, where on the hook you just have the halibut lips and you don't have the animal. That's a common observation. And we definitely had orcas around. Those 2 that you see in the image on the right were quite aggressive. They would come barreling straight at the boat, which was oddly disconcerting. We're at sea on a big 50-foot boat, or relatively big compared to them. and you're kind of like, you guys are gonna stop, right? Like they're just charging at you at the surface. And then there's another group, probably 100 meters away is the main group, and you can't really tell what they're doing. Are they just sitting there breathing, or are they diving down on your gear? What are they up to? So, but these guys were quite intent on being around the boat when they were around. So to your question, yes, we had cameras on the gear to try to quantify what was going on. So in image number 1, that's what we call the long line cam, and that was on control gear. So we had sections of gear where we would not deploy the shuttle, see what kind of catch rates we would get, both in the presence and absence of whales. But that camera would just float slightly above the gear, and it would turn on 45 minutes before the estimated haul time and start recording. And the goal of that camera was to try to see some of the depredation behavior as the gear went towards the surface. The next 3 cameras were all on the shuttle. The second one is an external camera, and it had 2 different locations. We had to adapt where we had it sitting. But it was meant to look for fish that got excluded from the device. So they came up to the device and they were either too big or something happened and they didn't make it into the device. And then 3 and 4 are together combined inside pointer, but that device you see inside on both 3 and 4, there's one camera pointing towards the entry door and another one that's pointed towards the back of the device, and it's inside that housing, and it watches animals being released at the release point where the hooks exit the device and go out the back. And you'll see a bit of footage on that. Might have to hit it twice. So at any rate, this is the internal rear facing camera, and it is looking for pass-throughs. There should be, sorry, they're not. Black on. Something's going on. There was black cut there. Yes, yeah, it's not showing the full slide here. I'm not sure why. At any rate, this is the external camera, and it is, there should be 2 images here, one on the left and one on the right. I'll see if I can.
PDF on the SRB website has the.
See if we get into play here. Yeah, it's not wanting to show up, but this one's kind of showing it. So that's a sablefish that's getting excluded to the outside. We also had examples of halibut getting excluded to the outside, sometimes rockfish.
Just by chance, like just a error?
Possibly. Sometimes it's related to the length of the ganion, and if the animal kind of slingshots around the outside of that collar, it kind of flings it off. It's not well hooked. There was also quite a bit of sand flea activity going on, so that you may have had some poor integrity bases, and that the animal just kind of sloughed off. We also anticipated that large skates, large halibut might get excluded based on their sizes. So pass-throughs, this shows a halibut going right through the device. So this is the rear-looking camera, and that keyhole shape is something that allows the gear to go through. It allows the occasional snarl to go through. And in that image that we just saw, a halibut actually rolls up and goes through that little round spot at the bottom, which is surprising. We also had some cases where fish will go through, if they happen to orient completely sideways to that slot, they'll go completely through it. And sablefish would quite easily go through the larger hole at the back. This is looking at entrainment, so fish coming in and being retained. And if you could see the image on the right, you'd see that halibut coming in, and then the image on the right would show the halibut being released at that keyhole shaped device and staying in the device.
Is that a crucifier device?
It's not a crucifier device, but functionally, yes, it acts somewhat similar. It's completely, it's naive to how the hook comes out of the device. And so we were monitoring facial damage to the fish. What was the hook removal injury? And we have data on that. We don't have it summarized in this talk, but there's certainly, we know from our pilot work and from this work that the standard 60-knot circle hook does fairly substantial damage like it would with a crucifier. And that with smaller hooks and softer canyons, you're pretty good to use that. There's a few other options that could be tried to minimize that, but right now we're not focusing on those aspects. But we want to have it fully documented to answer those questions on kind of damage being caused. And then we also had escapees. So these are, this was a common observation on this work, where you get sablefish that kind of drift right back out. Now, what you're seeing in this image, she doesn't show it up there.
With the hooks, the hook's already taken out.
Yeah, so these fish are already, they're already internal to the device. The hook is no longer in them. And it doesn't show it well on that picture, but at my screen's showing something different. But the round object that you see kind of at the top is the stopper that it's encountered. And the stopper is kind of two pieces. There's a metal piece that's meant to close the door. And there's a kind of a rubber piece that's closing that little round part of the keyhole at the front of the device. And they're supposed to work together to lock the thing closed and then head to the surface. Looking at the footage afterwards, the rubber stopper was engaging first, and the secondary stopper, the metal stopper, is too far out. It's not fully securing inside the collar of the device. And so as it's heading to the surface, you see that sort of behavior that you see there, where the animals can just drift right out. There's very little current inside the device, and they can drift right out. And so we've been going through all that footage to summarize how many of those things are happening. This is an easily fixable problem that we didn't have the time to download and review the video footage while we were out at sea, but it would have been helpful to have known that, because we could have easily fixed the length of line to stop. But it's certainly a fixable thing. I apologize for the videos not working. We'll see if we can do something with that at lunch or something. So this is just some preliminary results. Again, we don't have all the sets evaluated yet, but out of 89 Pacific halibut encountered, 1 was excluded to the outside, 88 came in, none escaped or drifted out. 8 of them did pass through the device. They happened to line up with that keyhole device or tackle out, like you saw that one fish go through. And so you see an entrainment rate of about 91% on those sets that we did.
Those fish ended up getting on the boat.
Yeah.
But they just were not protected as they went out.
So we monitored whether they came onto the boat or not. Those aren't summarized here. This is just from the camera work where we saw 8 of them pass through. And we did see fish at the surface, but those fish could also have, we haven't done that comparison yet, but in theory, fish could have fallen off after they passed through because they got damaged or further roughed up. They could have gotten depredated as that gear continued up without the shuttle. Or if they were badly sampled, they could have fallen off as well. So there's a couple options there, but we do have data on that. We don't have it all fully summarized yet. For sablefish, we had higher encounter rates. We only had 2 excluded. We had a lot of escapements, and again, largely because that stopper wasn't properly closing off the entryway. And we had a reasonable number, like 20% of them passed right through. Again, the shuttle can be modified to reduce the size of those openings to increase the retention of sablefish if that's desired. Similar with peacod, we had more escapes through those, and some pass-throughs with them. Rockfish, we had a fairly high exclusion rate, and that appeared to be largely sand fleas. They'd come up, they'd ricochet off the collar, and they just peel off, but there'd be a giant cloud of sand fleas left behind. So we know he had some problems with that. And then skates, we also had some exclusions. We had no escapes of those, and only 2 pass-throughs with about 87% trained.
I'm trying to understand what this means for like the economic viability. They can retain sablefish.
If they have quota for it.
And peacock, rockfish, and skates are not economically.
Depends on where you are, which fishery you're in. So again, if you have quota for it, it may be worth you keeping it to fill up your quota and based on prices, but they'll often be targeting either Pacific halibut and or sablefish. And so certainly the Pacific halibut and sablefish are big targets for depredation. And so those would be 2 that they'd be interested in, as a fishery trend that they'd be interested in retaining.
And so looking at that sablefish, 28.5% escaped. You said that's a totally solvable problem just by changing the line, but the pass through of 19%.
I think that's, you can reduce that as well. Maybe small sablefish, you cannot stop going all the way through, but I think you could probably easily have that. Rockfish, like I said, I think it was a function of the sand fleas that we were in. So I think you'd get better retention if you didn't have that happening. And skates, it's a function of where they're hooked. Their mouths are they're cartilaginous. Their mouths are gonna give way quicker. If they're too large to enter through the opening, that's gonna create some resistance, just as the keyhole would create resistance. So that the hook may pull out and they may not enter into the device. But again, I think species morphology is primarily what's causing those animals to change their retention outcomes. Large skates, large halibut may get excluded to the outside. I don't think a lot of them are, according to this. But certainly on escape rates, those tubular animals, based on this current function, were much easier to get out of the device. And that's the front entryway. It's really easy to close that off properly. Two ways: you can change the tines to the entry door, and you can make sure that the stopper is properly plugging the hole. And then the shuttle also has holes throughout it to allow water to flow through. And if you're having too large a hole, you can easily change the size of those holes, so that restricting who can get out, but water still coming in or flowing in.
Typically happens to skates. Are the whales interested in the skates at all?
From what I understand, they're not. You'll often get skates on your gear when you have no halibut left on your gear, no sablefish, or you're getting lips and heads of those species. And skates are generally untouched, but not always.
And then they release the live.
Correct. Yeah, correct.
So this is a significant source of mortality for skates.
I would say the injury profile on skates. They're generally pulling the hooks through skates, whether it's underwater or there's no careful use of water skates.
Really?
Yeah, so we have
release. They don't pull the hook with a gap, just to twist.
They do, but it's not a twist. It's usually just pulling. And a lot of times on a big skate, the hook will pull through as it reaches the water.
They often just pop out. Skates.
And how does it come out? Does it kind of rip the
Rip
the lip off and comes out?
It will take the lip, or it'll break the bottom jaw often. So, and we have injuries on all the fish, including those that made it to the surface. So we know what kind of injuries they are sustaining as the fish go. Obviously on a fish that gets excluded, we can't tell what its injury was down there. But we can certainly tell what the injuries are at the surface. So we'll have those summarized as we go through all this. We also were able to capture some footage of killer whales swimming around the ground line. This is an amazingly challenging thing. There's been a bunch of researchers who put cameras out trying to monitor depredation behavior, and it's infuriatingly challenging to actually get imagery of them doing it. But we were able to get some imagery. I'll share a little bit that hopefully it'll show, otherwise we'll find another way to show it to you. This is not looking at cameras. This is actually data from the surface. So data we collected at the surface between the control gear in the left in the blue column and what was caught in the equivalent amount of shuttle hooks in the orange by the sets that have been reviewed. And the little whale fin shows you sets that we had whales on. This part shows that we have a lot of variability between the controls and what we're seeing in the shuttle. You would kind of hope to see, like set number 7 have a whale fin over it. We don't have that. Set number 7 does show that the shuttle can entrain a decent number of fish. That's about 1,000 pounds of fish in that particular shuttle haul. Number 8, we got no halibut on the control, but we got some halibut in the shuttle. But then number 10, which we got really excited about, the light blue is lips only. So we had 20 lips only come up on 200 hooks. So 10% of them had that. And we had 2 or 3 actual halibut or damaged halibut on it. And then we get to the shuttle and we're all excited because now we're going to see the shuttle outperform. And the shuttle has redfish in it, has a completely different composition of fish in it. It's got a bunch of rockfish in it. which this set had on the control had none. So it seemed like from that and from the depth profiles of how the gear soaked that we had actually drifted that section of gear into different fish habitat, which is disappointing. It's not, it makes it harder to tell the story, but certainly we're seeing that the shuttles are capable of getting good retention of halibut in them. We've got really variable results on that. We had some other uncontrollable factors that popped up with, like I suggested, the species composition showed itself on set 10. We also snarled up with crab pots twice, and we're not sure how that affected fish coming into the shuttle itself. You can see it on the cameras. There's this big crab pot right in front of it, and hooks appear to be coming in without fish on them that probably had fish on them where they've been sprayed. It's really hard for the cameras to pick up what happened there. So again, this is preliminary data, so we haven't gone through all the data on this yet, but that's an example. Hopefully this next slide works.
All the missing sets there where you get one through 17. There's only 8 shown.
Right. So some of the sets did not have the shuttle deployed, either due to safety, weather, or a couple times we had to haul the sets in reverse order. So the stopper you were gonna encounter the stopper before you encountered fish, and it had to do with changes in tide and weather. We were really bucking the weather in the Bering Sea on this one. So, and some of them just haven't been reviewed yet. So I haven't.
Oh, okay. So there's potentially skating.
Yeah. And so I'm hoping this is going to work on here. We'll see. Yeah. So this is one of our whale encounters. We'll see if you can see it. This is. Oh. So this is the control gear. And this is at about 525 feet deep. So I'm just going to run that back again. The tendency here is to look at the snow in front of you that's lit up by the light. You want to look in the lower right-hand quadrant in the dark. What's happening here? So they are inspecting it. They're taking a look at what's on there, and they were likely on the hooks, but we don't see them actually depredating. The other image we have of a whale coming by, or possibly 2 whales, is from one of the shuttle cams, and we're up close to the surface. We're in about 30 feet of water. The water's very green, and you see these ghostly things go by. They're kind of going to drive by past the unit. But so we got some footage of that, but not the classic. How are they actually taking these fish off the hooks? We had some classic imagery of, halibut dangling. You can see the hull in the background, this kind of ghostly hull shape. It's all nicely backlit for us, and we should get any whales coming in and taking during those times. So, but overall, a very successful effort, and we hope to have a slight extension of the work happen this fall out on a quota trip with the sampler board to do some quantification for us. Still to come on that. So the final conclusions are that the unit can be safely deployed and retrieved, especially if you have a picking boom. There's good retention of halibut. It could have some simple modifications to increase retention of Pacific cod and sablefish. And then some next steps that we're looking at that could help foster using this tool include a regulation change that might allow full retention of all sizes of Pacific halibut when using the device. That would allow us to not have to worry about kind of the crucifying aspect of the device, in that when they're using it, they just bring everybody in. It's probably not the best plan to be releasing crumbs and cookies to hungry whales to begin with. So it doesn't make sense to be releasing fish in those conditions. We can look at weaker ganyons, softer hooks, or modified hooks to reduce that hooking removal damage. And then not every vessel can take a device that's this size. And so I think once there's evidence that the device works, We can look at collapsible designs, snap together designs, that sort of thing to make it safer for stowing and transporting advice on different size figured vessels. And then lastly, kind of to the discard mortality of fish that are being released by it. Ian produced a spreadsheet yesterday that we're looking at kind of what the trade-offs are on that, what causes greater mortality, losing them all the whales when there's no device, losing them to whales and feeding them back to whales, just the sublegals, or retaining them all together. And we're just starting to play with that now, but it may help us answer some of those sorts of questions that we're inevitably going to get.
What's the hook removal damage concern? Is that like marketability or animal welfare?
It's in animal welfare. So right now there's a regulation on the books that requires us to release all sublegal fish with minimal damage. And so the way the fishermen normally do that is get to the surface and they know it's going to be sublegal. They'll engage the gaff into the crook of the hook and twist it, and the hook essentially goes back out the way it came in, and it leaves like a little earring piercing kind of thing in the cheek of the animal. And they often heal that over from new tagging studies, right? Right. But this has more tearing and breakage damage, which increases the mortality on those fish. So that slightly less likely in some cases, or a lot less likely in some cases, to survive their injuries. So it moves more fish from the traditional estimate of mortality into a higher rate of mortality.
So we're interested in quantifying that trade-off. What level of whale depredation would you need to offset the additional mortality release? What's that?
And then this last slide just points to in the presentations this morning. This is a summary of the remaining grants that we have on the projects we presented. So we're finishing up the depredation project here, number 1, and then the methylation project is number 2, the methylation aging. So
is the methylation aging that inexpensive, or are you heavily subsidizing it?
Yeah, I think that was the secret.
Yeah, I can answer that. As you can see from the budget, it's not a very expensive project, the development side. How that's going to be translated into more of a routine or monitoring aspect, that depends on the technology that we use. So in fact, the development is covered by the development of the clock is covered entirely by the grant.
Okay.
And we're looking for ways to see how those set of age-related CPGs are going to be quantified, probably with other techniques. So it will just be a matter of finding out once we have the clock developed how it can move forward. It's probably going to be much cheaper, but I cannot give you an estimate right now of how much.
That's not what I was asking. Just whether 60K actually covers the development of the epigenetic aging, and that's pretty impressive that it does.
Yeah, it does.
Is that the entire project budget, or is that just the IPHC
internal? No, that's just the IPHC. The full budget is about 90,000 because this project was submitted in collaboration with Alaska Pacific University, which is the PI of the grant. Alaska Sea Grant requires that it's an Alaskan institution submitting the grant. We are leads, but we're actually not the PIs, just for organizational reasons. So the full budget is 90,000. 60,000 goes for the IPHC, and this does not include the salary and tuition for the master student. That comes out of this budget. I'm sorry, it's not included in this budget.
I see. Okay.
So Alaska Sea Grant provides basically 2 budgets. One is for the research project, and the other one is for the associated master student.
Okay, got it.
What I think I heard last week is that this could cost $50 to $70 per sample to age a fish. Does that ring a bell?
No, not really. That's really hard to estimate at this point because the development of the clock is using a technology that is not going to be used for the implementation of the clock. So it basically depends on what techniques they're using for the clock once that clock is in H production mode, and that's it's impossible for us to say right now. That seems, if you're talking about $50 to $70 per sample, that sounds really high. I mean, that is possible if they go through a commercial company to do that. Those kind of rates would be compatible with those kind of sort of company agreements. But if that assay is developed and the clock is actually implemented in-house in their own laboratory, costs those costs to me sound high. I don't know what Andy, if Andy can weigh in, but they seem high to me.
Yeah, I think, yeah, that seems high to me. That's more like, that number seems more like we would apply to like the development side of things. When you move into like the more production phase, those numbers should come down. So yeah, roughly, yeah, that's kind of what it is, for example, for this phase, but.
Going back to what I was saying before about the research plan, having an idea of what those eventual sample costs would be is really important, because I think that really determines whether this is super promising avenue or one where the costs are just never going to be justifiable.
We did have the experience though with our genetic sex assay that when we first did development on that, it was going to be $17. And so we went a whole different route, and we spent 3 years doing a field project, mark the fish, and then we came back, and Joseph, we're doing it now for like 70 cents a sample or something.
Wow.
It's last estimate I think it was under $1, definitely.
Yeah. So it went from prohibitive for us to ask the fleet to do the work if we can do it. So and that was in a course of 5 years.
Wow. So Joseph, is that what you're saying, that the costs are just going down so rapidly that it's not worth trying to predict, or what is the uncertainty in the eventual cost?
Well, there's two. I think there's two components of that in that uncertainty. One is the methods that are being developed. So new methods are being developed. There are a variety of methods that you could use for implementation of this clock. So, from multiplex PCR to a solid assay like an array. There's a variety of different systems that are being developed as we speak. Even digital PCR. So it's very hard to predict. In, let's say, in 2 years' time or 3 years' time, when we're actually ready to implement this, the techniques available for doing this are going to be different than the ones that are available right now. And also the prices will be different. So that's why I'm quite hesitant to predict what could cost us in 3 years' time the implementation of the developed clocks that we're doing here.
Okay, but maybe I'll ask it a different way then. How much would it have to come down to be competitive with doing the aegis manually? What's the cost of it?
I think we should do a cost analysis in that sense. I can't answer that right now.
This would also, if it were to work, would allow you to age fish that you handle once, tag, and release. So you don't want to pull their otolith out. You don't want to have a fatality there, right? Yeah. So you may not end up using the technique for production aging necessarily. You might use it for other projects that we do, where we want to release the animals live and have an idea of what age they were when we release them and how they're behaving, etc.
Yeah, I realize there's multiple use cases, but it'd be good to see like which ones are ever going to pan out as economically viable, and how much resources you put into this depends on whether it's going to be sort of an add-on for research projects or whether it's going to replace production aging. And knowing that cost benefit would be useful, given the uncertainties with how rapidly the genetic costs are changing.
Yeah, again, it's hard for me to say at this point.
Okay, so we're at a juncture here. We've got 40 minutes to lunch.
Happy to get started. You got energy.
We'll just pick it up with the stock assessment.
Great, thank you. Looks like I have.
Could I be elevated to presenter as well, please? Okay. So this will be the update from on work on the stock assessment since our June meeting. Just to refresh you on the process, I'm going to first refresh you on the process, and I'm going to go through the list of requests that you made in June. And I think actually also looping back to one request from last fall, which was a comparison of commercial CPV and fishery independent setline survey. And then I'll just refresh your memory on the steps walking through finalizing the 2025 stock assessment. I think so. We had 7 total requests from the last 2 meetings that were outstanding. So just to orient you to the process, Dave mentioned this at the beginning of this meeting, but our stock assessment review process is to conduct a full stock assessment approximately every 3 years. We've been on that schedule now since around 2015, although we had one extra year in there. The full stock assessments are intended to reevaluate all the data sources, model structures. It's kind of all the decision making that goes in, and that was the primary analysis that you saw in June, was that full rebuild of the stock assessments. In the intervening years, we're doing update stock assessments with the intention of making only minor or necessary changes as data sets and things evolve. It doesn't mean we can't make changes in the intervening years. It just means that for the process itself, it has seemed to work quite well to limit our major changes to every 3 years. This also has the benefit of keeping in step with the MSE process, which is that if I'm making major changes every year in the stock assessment and Alan's only reconditioning the MSE model every 3 years, then we're kind of essentially always eternally out of phase. Whereas if we do both of these things every 3 years, we're in lockstep essentially. So in June, you saw the big document on research and development, all the way back to the raw data sets, rebuilding the models. The recommendations you made in June were primarily to the Secretariat. As Dave mentioned, at this meeting now, we are finalizing the assessment approach and planning for next June. So in terms of recommendations to the Secretariat, it's helpful to delineate those that would be relevant for this fall stock assessment versus those that are more research focused for next June. But then you also have the opportunity to make recommendations to the Commission at this stage if there are aspects of the assessment or the results or the interpretation that as you see fit. And as you'll see, some of your requests did get more to communication results than necessarily the technical results. I put all the requests on one slide just so that you can go back and cross-check these as you'd like. I'm not going to read them all, and I'm just going to paraphrase them as I go through each one. And the first one was actually quite interesting. So this was from last fall, and we didn't get to it in June, but the request here was to begin comparison between commercial CPUE and FIS WPUE, both at the coastwide and the regional levels. We did not do a full simulation experiment, or which is kind of what was suggested by this
recommendation, but instead we said, look, let's first evaluate the raw data and try to understand what patterns we're seeing in the data, and maybe that will be the springboard to the next step of trying to understand these data. So the first thing we did was to summarize the Fishery Independent Setline Survey annual coverage back to 1993, which is the first year that we standardized the space-time model. So what you can see plotted here is the proportion of stations sampled in each of the 4 biological regions and then coast-wide. So the black series, which is a little hard to track because it's almost underneath some of these. Oh, you can't see my cursor, can you? Never mind. Yeah, it's mostly under region 4 through the middle of the time series. You can see that early in the time series, we had pretty reduced coverage. We had a period of fairly stable, but definitely not complete coverage during the 2000s. And this was previous to our survey expansion efforts, where we added approximately a third of the stations that are in the current 1,890 full station design. You can see a couple years there where we got close to hitting all the stations in a particular biological region, or did hit all the stations as we completed the expansion project, which was done in 2019. We didn't, of course, never had the resources to do the full 1,890 in a single year. Then you can clearly see the effect of COVID in 2020, where we had pretty good survey in region 3. We had a little bit of survey in region 2, and that was essentially it. Not much else during COVID. And that was also the year when the NIMS trawl survey, which is included in the region 4 sampling here, also did not happen. Then you can see, especially in these last 2 years, 2023 and 2024, the challenge that we've had with budget and having a full survey. You can see that our coverage rates for particularly region 4 dropped pretty sharply. But also region 3 as well, particularly in 2024. So 2024 was one of the smallest designs that we've had since the early 1990s. So we wanted to categorize each of these designs because what we're interested in is whether or not, when we have reduced designs, we do or don't see a different relationship between the trend that we're getting, or the CPUE that we're getting in the Fishery Independent Setline Survey, and the CPUE that we're getting into commercial fishery. So plotting those two things against each other, just the straight raw CPUE, they're on different scales. And we've categorized, so there's some really interesting patterns here. Just to orient you to the graph, so this is Fishery Independent Setline Survey, 032 WPUE. So we've limited to legal size fish so that that's the most comparable to the index coming from the fishery WPUE, which is net pounds per skate. So those are effectively the same thing. And we have the rows are coast-wide across the top, which includes all the data in the rows below it, and then each region separated out. And then we've also categorized these into broad and reduced surveys. Now, I do want to go back here for a second and just to note that the reduced surveys are going to occur at the two ends of the time series. It's not a random sampling. We don't really have a good, they're confounded with the underlying trends that were going on.
So you could generate reduced sets.
We could, and that may be the next step. But what I just want to be clear to point that out. And so again, these are on different scales. So obviously the fishery on average is going to have a higher catch rate than the survey, which is on a uniform grid. So the first thing we did was just to standardize these by dividing by the mean. So this essentially takes Q out of the equation. So now with Q removed and the gray lines are a 1-to-1 line, I think it's a lot easier to visualize the linearity or non-linearity series. As Olaf mentioned under his breath when he immediately saw this, there may be some evidence of hyperstability here. For example, if you go to the bottom right-hand corner here for reduced surveys, and I can't get my mouse to go up, but you can see that there's the if you're moving from the center of the plot to the left side of the plot, the survey is not going down very much, but the fishery is dropping substantially. However, the same relationship doesn't seem to hold at the upper catch rates. It's actually the opposite relationship at the other at the high end of the catch rates. And I think that pattern is most pronounced in region 2 and region 4B. And these are places, these are both areas where we did have, we've had substantial years of reduced surveys in both areas. In areas where we've tended to have better coverage, and perhaps even in, to some degree in Region 2, when we've had better coverage, we're much closer to the 1-to-1 line. I should have noted that the crosshairs are representing the error on both axes. So this is an errors and variables problem. There's obviously uncertainty in both of those. And we haven't fit any statistical models to this. What we wanted to do first was just to provide some visualization of the data and a little bit of preliminary interpretation and a chance to talk about this. So I was expecting we would take some time here on this slide to think and discuss what we're seeing here. I guess another observation I will make, particularly for the coastwide, just looking at coastwide, either all years or the reduced surveys, there's that time period when we have relatively high abundance and effectively no relationship between fishery and the fishery independent setline survey, but very broad error bars, particularly on the fishery independent setline survey. So that's early in the time series. We had very poor spatial coverage. Pretty sure there was a lot of biomass out there, but not much precision. So not maybe a great comparison.
Yeah, I mean, coastwide, it doesn't look bad. It's the Region 2 that's particularly.
And 4B, I would say, both show the same pattern. But interestingly, that it's a full curl. It's not. If it were hyperstability, it would be flatter. But it's actually showing a different relationship at higher survey than lower survey.
So it's also.
It is. Yep. Yes, it is.
Yeah, I mean, it's not as much a regional effect as it is just whether you have reduced or grown, right? Because in Region 4B, it's all reduced surveys essentially, whereas in some of the others,
It's going to be a combination of both. So Region 2 and 4B are also the two regions that are probably the most heterogeneous in their catch rates. You're going to have areas of very high and very low catch rates. So the potential for the fishery to aggregate onto certain areas is going to be higher. And that, I think, is where we're sort of pausing in this analysis, which is that if we find that there are differences in this relationship over different levels of biomass, it's still not going to tell us which one is a viable index, because there's lots of reasons why the fishery is changing, and potentially on both ends of the curve. At the same time, there are lots of reasons to think that when we have reduced survey designs, we could be missing things as well. So it's kind of unclear where we go from here, to be honest, or what the goalpost is going to be. I would say I was somewhat reassured when just looking at the coastwide, whether you look at all years or broad surveys only, we're getting a reasonably good relationship between fisheries and setline survey, especially where we have good surveys. So one takeaway is it's basically right on the 1-to-1 line. So one takeaway would be when we do good surveys,
Middle?
yeah, or on the left there, with the exception of those early years, we have a huge amount of uncertainty. We get a pretty good correspondence, which is kind of surprising, really, because this is spanning a time period when the fishery in Alaska, at least, went from a derby fishery to a quota fishery, where they went from 24 to 48 hours of fishing to an entire season's fishing. And actually, some of these points at the very top would have been those, the points that are off the line at the coastwide level would have been points that occurred 93, 94, and then 95 is when the quota. So two of those points would have occurred before the quota program took place.
Interesting to see if you cut off all the data to the right to one line and then fit a hyperstability kind of power model between the two, what the power will be. So it doesn't, that power, it's one, then the conversion data is linear, but doesn't take a lot. Hyperstability to kind of.
Well, remember in the assessment, we allow random walking.
Yeah, I'm not saying.
So
yeah,
what we're trying to,
it's
what
not
we're
having
trying,
much
what,
influence
yeah,
at all, but
what we're trying to understand here, I think, is whether or not we have concern about the survey. Problem is, it's sort of a circular argument, because we know we already have concern about the linearity of commercial catch rate with the population.
I mean, I would even contemplate substituting fishery data for your survey, but I think when I was interested in this, it was more for communication, like, so you could actually, can you model fishery CPE? And it looks like you can do a decent job of it
In some regions.
in some regions,
And,
yeah.
and coastline.
Because I think part of the conversation we were having was around, especially now, like, is CPUE and relating that in the MSE work to see what does CPUE look like? Because that's really what fishermen are going to be interested in moving forward. And this suggests you could probably do a decent projection on fishery CPUE.
In terms of communication, I think that particularly in 4B, that does correspond to, at least anecdotally, what we hear from the fishermen, which is that their catch rates have dropped more in the last several years than the survey would indicate. But then we've had very poor survey coverage out there. And I think actually the survey observation you have from 2025 may give us a point that looks much more fishery. We had a fairly substantial drop in 4B this year.
Is that just because in 4B they're fishing very small spots?
A lot of 4B is very difficult to fish. It's very steep bathymetry. There's a lot of passes. We actually have a really hard time getting vessels to survey out there because nobody likes to fish in a lot of the areas where the fish are. It's also very expensive to fish in 4B. And so a lot of the fishing is in locations that vessels can get to rather than necessarily running another several hundred miles farther out the chain where potentially there's better fishing, but no one's been there in a while, so nobody really knows. There's a lot of reasons why fishing is very challenging in 4B, but not the least of which is that the biomass has dropped substantially out there, and we may or may not be detecting it all that well with our fishery independent setline survey and the reduced design. If we go back here, 4B is these triangles. At best, we are sampling around 40% of that area. We had 1 year when we sampled the whole thing. That was 2017. And then since then, we've never had sampled more than 40%. And in the last few years, we've only had 2 years when we had any sampling at all. We did sample 30 stations this year.
Oh.
So 30, but that's going to be 30 out of yeah, so better than nothing, but still
Cluster.
not a comprehensive. And they're in a cluster on the east end of them, so they're spread around. So it was interesting to dig into the data, and I guess at this point we're kind of looking for guidance on what you think would be fruitful going forward, whether this would be best turned into a communication tool, whether there's more statistical analysis we should do, potentially more simulation, kind of where to go from here.
No, I think this is helpful and probably a reasonable stopping point. It just shows what we already expected is as the fish coverage declines, we can't fall back on interest, but we as I said, do that already. Although, short term at the coastwide level, it's like it would get that.
I might have asked this before, but at the beginning of your presentation on the coverage, what happens to age the age composition, when you subsample these regulatory areas.
Yeah, we end up with subsampled age composition. We
Have you thought
we
about
can expand.
standardizing it in the spatial temporal?
We have actually. And there are a couple of applications that have done that, but to my knowledge, nobody's done it for two sexes and as many ages as we deal with. So the applications that have been done have a handful of ages and or one sex to deal with. So basically you're fitting a separate spatial temporal model that can share some parameters, but you're fitting a model to each age and sex category, spatial distribution. So for us, that would be 24 times 2 models together, which with our geographic extent seems pretty prohibitive at the moment compared to the published applications where people have done a geostatistical standardization composition data. The best one I know of is that's
You're
the
modeling the age composition. Like if you were doing it for a binomial setting, you're not doing a model of each class, you're modeling a probability distribution.
So the paper I'm familiar with was the one that Jim Thorson and Melissa Haltuck did for Linkcott. I believe that effectively it turns into models for each age or size category. I think they may have actually done size categories, but they combine male and female analysis because it's computationally intensive. I think they may be doing this for Pacific cod and the Bering Sea as well. They may have a geostatistical standardization of the comp data. The one thing that we do that is a step toward fixing this issue is that we use the output from the abundance-based geostatistical model to weight the age composition data that we do have. So we're not using a pure design-based estimator for the age comp data and then blending it with a model-based estimator for the index. We're using the numbers per unit effort expanded out by each strata to weight up the age comps. So essentially, it's not as good as fitting a spatial surface to estimate the age comps that we're missing, but it does at least account for the cases where we have, for example, more of one age or another in a IPHC regulatory area. Those are getting weighted by the numbers from geostatistical. So this is a relatively commonly used compromise between having a full geostatistical standardization for the comp data and not doing anything. Ideally, you could do the same thing with comp data that you could do if you only had a couple of age classes. Pretty straightforward, just model them directly and use all the same logic that applies to our geostatistical, our space-time model would apply to the comp standardization. Fill in the gaps if you had more old fish on one side of an area. And I have no doubt that this does lead to some lack of fit in the stock assessment because we've got sample the east end of one area and there's a gradient of age that we're certainly not representing that. So some of that's going to come out in terms of the tuned sample sizes of the stock assessment. We find that we can't fit the data quite as well as we thought we might have. That's inevitably going to be part of that lack of fit. It's the fact that our samples aren't randomly sampled from the entire population or even the region or the region.
I think it's really pity that for so long time the fish sampling was so stable. Like it was always the same proportion sampled, and then everything got mixed up because when it was stable, you could actually compare the differences between the years. Like it would give some sort of baseline, and now it's like we don't have it anymore.
Except that we found that that stable period was actually giving us biased estimates because we weren't missing a random subset of stations. We were missing certain areas of stations. And when we went and sampled there, sometimes we went and found no fish at all, and sometimes we went and found lots of fish, and it differed by area. And so as we did the expansion, it made a pretty major change on our estimate of distribution of abundance, because places, effectively, if we weren't sampling there historically, we were assuming the average catch rate in these areas. It turned out that wasn't a good assumption by a long shot in some of these areas, and not always in the same direction. In some cases, we caught a lot more fish when we did the expansion, and in other places, we caught next to no fish.
But so some station could be very abundant with fish 1 year and next year nothing.
Yes,
Whether you
although
just-
there is some temporal, we estimate the temporal correlation. Ray does in the geostatistical model, and there is an appreciable amount of temporal correlation. So it's not a complete redistribution.
Yeah.
We definitely gain information by using the temporal correlation.
Would that be connected to any oceanographic conditions or hydrological conditions? Like something that would predict what are the good places for halibut to be?
I kind of want to work on that, right?
Yeah, I'm sure there's some connections. There's certainly lots of the habitat which tend to have higher catch rates consistently. So maybe there are underlying conditions in terms of the substrate. Now, environmental conditions. But we've done limited modeling on those stakeholders. Trying to understand that. Not something we integrate into the production version. And things like in 2A, there's that we've had variation in self oxygen. That's a good predictor. Temperature is a weaker predictor. Possibly something.
And you do include depth.
Depth is routinely included, yes, because there's a strong relationship with depth. It doesn't change from year to year. Generally, in general, deeper waters, lower densities, shallow waters, smaller densities. That's not the same. Some of the best catch traps, the trees we have, deep water.
The other challenge we have is that we do collect some oceanographic data at every station, but if we don't sample the station, we don't get the oceanographic data. So its utility to use as a predictor isn't great. Unless we were to draw in another data source to use to predict at those stations.
Just wondering if knowing that kind of hotspots and knowing whether the fluctuations can be related to environment, and then there's the unexpected trends, how much they would tell maybe about the whole stock going up or going down or varying a lot. Like they could be used as kind of indicator stations. At least that would be very cost benefits, or kind of benefits compared to costs would be there in proportion, because you know where exactly to go to get knowledge the whole stock.
Right, and so that's essentially the process that we have now, except we recognize that those things shift over time. So what we're doing now, and Ray's going to speak to this later, is we have what we call a rationalized design, where based on recent catch rates, we're optimizing where we need to sample in a year. Because we have seen long-term changes in where you would need to sample to create that kind of information. It's absolutely true that we don't need to sample the full design every year, but the areas that are going to be most important do tend to shift over time because these fish do move around and the productivity of different areas changes over time. So we're essentially using a rolling approach to indicator stations and sampling, as many stations as we can. But we would never propose sampling all of them in a single. Get by with about 2/3 would be our optimal design with a rotating piece to check. That was the other thing, is that some of these areas, for example, the inside waters in British Columbia, when we sampled there were no fish. effectively no fish. But historically, we know that there was catch in that. And so we can pretty confidently say we don't need to sample it very often. But we really can't write it out of the design entirely. We're gonna have to go back on a period, maybe 5 to 10 years, and at least verify that the fish levels hasn't changed in these areas. So even the low density areas, I think we would hope to be able to sample all of the stations on a rotating basis, with the frequency being dictated by how important they are to the coastwide estimate, and that's described later on.
It's almost similar to Volga Port situation, that when the stock goes down, then it used to be everywhere in the Gulf, Finland and Baltic Sea, that when the stock collapsed and went really down, there were many places that was completely empty, no cod was found, and then they were aggregated to a very small area, but there they were abundant and even maybe starving a little bit because they had all aggregated there.
I'm gonna sneak in another. Well, this is a quick one I can fit in before lunch for sure. So this recommendation was just to maintain the new maturity ogives in the 2025 assessment and hold on fecundity until we get to 2028. We had several questions about this at the work meeting as well, and I think people are comfortable with this approach, us taking a very stepwise approach and not jumping into a fecundity analysis before we really have enough to be sure of what we're. But I did try to warn the commissioners at the work meeting that fecundity has the potential to make a pretty dramatic change in our perception of stock status, productivity. Find a strong fecundity relationship where it's a linear relationship with size, weight. Particular, has the potential to change our reference points and perception of biomass out there. As an aside, it's interesting, in our discussion about cost benefit this morning, knowing what we know now about maturity, we might have downgraded the priority of that a little bit because we actually came out pretty close to the historical curve that we were using. But we didn't know that going into it. It could very well have made a big change in our perception of where the stock status was. So I think we need to make sure that we're able to categorize that as a big success, because we've gone from using a 20-year-old outdated maturity schedule to something that's based on histological methods. It's updated. It's now using 25 years of recent data. And so even though it didn't create a major change, which I think was a relief to a lot of people, still, I think, a really great example of the successful feedback with a major source of uncertainty, do the work, bring it into the assessment, and now we produce that source of uncertainty.
You've used 25 years of histological data?
We calibrated the visual curves back to 2002.
Oh, yeah, because I was going to
Yeah.
ask, like, are you going to back? Is it I was wondering, like, do you know that those old ones were incorrect? So you're correcting the entire history based on the recent histological.
Yeah, that's one thing we've had discussions about, is we don't know whether or not the difference between histology and visual has changed over time, because we only have 3 years of comparison. But we've implemented that 3 years back to when they changed the surface to break and burn aging method, which was 2002.
So we're using all the data that we have and calibrating based on them. It's very recent. And we'll learn more as we collect.
Yeah, we're going to collect more in years, and we'll see.
So as we get more data, we'll be able to speak and analyze better the potential for temporal variation.
Well, that's what I was going to wondering. How do you know it's not a temporal variation? What part of the difference is temporal variability, a trend? I guess you can't do it.
There's both going on. Yeah, there are some temporal trends, but we need more histological.
Yeah, we need more years of data.
No, I think this is absolutely a great example of the biology, the stock assessment identifying a key uncertainty, biology program, addressing that uncertainty and results. The fact that it didn't change things a lot is neither here nor there in the
And hopefully we'll have another good closed loop time for the 2028 assessment, at least with some initial. Estimates. This is another quick one. You can take before lunch. You just highlighted that endorsing the changes that have been made through June and bringing those forward. So everything that's been done since June was based on what's that came out of June. I think maybe the next one is a real one. Yeah. So maybe we should wait on this one and hit this one after lunch because this actually has some model runs discussion associated with it.
Okay, well, let's break for lunch. Pretty much on time. So we'll be back at 1:30.
Okay.